close enough? Get away.
Right. Thank you, everyone. I'll introduce now Eduardo again, who will be moderating this panel. Eduardo, the floor is yours.
Thanks, Roberto. Can you hear me? Is that okay? Yeah, great. So welcome everyone to this morning panel on global water utilities, navigating uncertainties and lessons from the UK and the US. We have a distinguished panel here, Geoff Darch, who is the head of strategic asset planning at Anglian Water, Martin Andrews, director of major projects and markets at Ofwat, Aaron Silas, who is assistant vice president at Central State Water Resources in the US, Commissioner Eric Skrmetta, who is the public service commissioner for the state of Louisiana in the United States, and finally Tim Williams, strategic growth and business development director for water at Stantec. So thanks so much for joining us. And we'll have two rounds of questions. We're going to start thinking a little bit about the challenges in the US and in the UK, and I'm going to start with Commissioner Skrmetta. You're the Public Service Commissioner for the state of Louisiana, regulating essential utility services, including water for the state's approximately 5 million people. What should the UK audience know about the system that you regulate? What are the characteristics of this system, and what are the challenges?
Well, in the state of Louisiana is approximately the same size as the country of England. So, but what we're different is I think there's only about 15 or so actual water companies in England itself, where in the state of Louisiana we have probably 1,000 small water companies that are outside the municipal districts. Our commission does not regulate the municipal systems, we regulate private systems. What we've done over the past couple of years is work with the water quality divisions of our state, which regulate drinking water, and the wastewater divisions, which regulate the sewage systems. And we regulate the financial aspects and the economic aspects of determining rate structure, investment, and recovery. And what we've worked with our water quality folks is they've developed a scorecard for determining water quality and drinking water quality. And in doing so, it's helped us establish a couple of things. It's helped us to determine which companies are performing properly, which companies are not performing properly. And in finding that, we know that the companies that are, the grades are very simple. It's A, B, C, and D. And you don't want the other one, the F. We move forward on those, and we look for mechanisms to fix these. A lot of times, we're talking about smaller companies who have been effectively land developers. Unlike the United Kingdom, which are not traditionally subdivision-driven, where people buy plots of land and build individual homes. In the United States, that's a traditional mechanism, particularly post-World War II. And so we have a number of subdivisions that, in order to get people to buy land, the developers put in what I would call simply adequate water systems in order to have people want to purchase the real estate so they could build a home. Since World War II, the aging out of these systems is becoming predominant. And so these systems have to be rebuilt. We know that a lot of folks don't understand this. I particularly like Dr. Hill's doom loop analysis that he provided. And so looking at this, we look at it almost the same way, but with a combination of sort of an airline pilot's OODA loop of how to recover from a doom loop. And so we look for companies to come in and take over these systems and build them out. In fact, at our recent meeting in November, which just took place, I issued a directive to the companies to do a measurement standard of determining the amount of water drawn from the aquifer, the amount of water delivered to the homes, and look at the differential between that to determine leakage. So we can look at long-term necessity of pipeline replacement, et cetera. But we're in a position where hard decisions have to be made. And we want to make sure that as the only utility that people actually consume, that we want to make sure it's at first quality And so our commission does more than water. We do water, natural gas, electricity. We do a variety of other smaller things. But water is one of those ones where it's becoming actually more expensive to do than providing for the other utilities, simply because they tend to be smaller, incongruent systems that are not joined into larger systems. So in order to make them more valuable, it is actually a better situation when we can find companies that can come in and increase the number of water meters in the denominator of the equation. So we can get a better division of cost associated with it. And there's no shortage of small companies that are really substandard operators, and we find them more and more every day. So we're in a position to where we are improving on our water quality on the substandard ones that we've been able to determine through the grading system. But at the same time, the costs are going up, and it's, hard decisions have to be made about raising water rates. And so while water may be free, which all water is free, pipelines cost money, and water treatment facilities cost money. And we have to find our pathway to make sure that that is taken care of. And as we're looking at future environmental issues that are associated with this, we're going to be fighting, how that's going to be redirected against who's going to be paying for these things, whether it's going to be the consumer, whether it's going to be the water company, whether it's going to be the polluters. We're going to be fighting enormous battles on that. But right now, our biggest concern in our state is, and I think you'll find across the rest of the country, in fact, that map showed water quality issues are predominantly rural. There are some large cities that have had historic problems from aging infrastructure. That big money has to be spent. And the nice thing about big money, and think we were talking yesterday about London in 1850 with its wastewater on rebuild along the Strand, and that has lasted some 180 years, and they're now in the position where larger development is going to have to be made. But that money and that investment has lasted a long time. So investment that can be explored over longer periods of time to lower costs and provide for adequate types of infrastructure, I think are going to be important as we look at developing water mechanisms that are going to be valuable to the public.
Thank you. Thank you, Commissioner. And I want to ask Aaron to, as a follow-up on this kind of learning trip that we're taking to the United States, Central State Water Resources, the water utility that you work for, works across 11 states in the U.S. So I wanted to ask you, what are some of the commonalities and the differences in your service areas in terms of challenges and opportunities?
Yeah, absolutely. So Central States Water Resources, we operate about 1,000 plants over 11 different states. So I think, in terms of similarities between all of those 1,000 plants across those 11 states, the primary one is what I'll call hyper-fragmentation, right? So like Commissioner Skrmetta was talking about, some of our water systems serve as little as 5 people total, right? And when you think about the quality of water that those 5 people get, they deserve the same quality of water, the same safe, reliable standards as a system that serves 200,000 people, right? And so the level of investment that has to go into these extremely small systems doesn't really differ that much from larger systems. Another commonality I would say from our footprint really has to do with a lack of trust in their water and sewer services, right? So my company comes in and we acquire systems that are decades old. So they're 40, 50 years old, and they have been run improperly and have had a lack of investment throughout that entire 40 to 50 year time span. So we come in, we acquire these systems, and they've been receiving subpar service sometimes for their entire lives. And so whenever we come in, there's an automatic lack of trust there between us and our customers, the ratepayers, really. And that presents a slew of standards, a slew of problems that I've seen, a lot of community meetings, a lot of kind of work to build that trust back up. But as you're kind of increasing rates and making the investments, which take years sometimes, that lack of trust is really persistent. I think in terms of, what makes our footprint different from each other is we operate in states like Louisiana, Commissioner Skrmetta's state, where it's water rich, right? There are plenty of water resources to go around. However, there are weather problems, right? So hurricanes, and we have to kind of put a lot of investment into our systems, into resiliency. Kind of across the country, a state called Arizona is very dry. It's a drought state, right? So the water supply is limited. However, there aren't hurricanes. There's not a whole lot of resiliency that has to go into those systems. So wide variability kind of across our footprint, but all of them, financial distress, lack of trust, and really kind of all having to deal with the same emerging contaminants, PFAS, stricter standards, et cetera. So all need heavy investment, but vary pretty widely.
Thanks, Aaron. And now we'll come to the UK. Geoff Darch, Anglian Water serves about 5 million people with drinking water services and about 7 million people with wastewater services. Are some of these challenges common to you as well? And I think you, in a call that we had to prepare for this conference, you said that your job is a little bit trying to catch up with reality. Can you just unpack that for us? Thanks.
Yeah, thanks, Eduardo. Morning, everyone. Yeah, I mean, our challenges are very similar to those that have been mentioned. I mean, we serve in the east of England, so we're facing into some pretty acute challenges around climate change. We're the fastest growing region as well, so we're adding 50, 60, 70,000 extra people to our water supply area every year. And we're also faced with needing to leave more water in the environment, and that's a big challenge because it's changing the nature of the supply system that's been built up over a century or more. So yeah, we're absolutely facing the challenges, and we're in a tricky spot at the moment because we've got new infrastructure coming, so some new reservoirs, for example, but they're going to take time. And in the short term, we're faced with having to actually restrict the amount of water that we can allow new non-domestic supplies to receive, which is clearly not where we would want to be. So I think we are playing catch up on that respect, and we have a decent system for doing elements of the planning. And Jim referred to the water resource management plan, and that's identified these new things. But equally, we've got to start looking more at the sort of asset base and how we're looking at that. And I'm pleased to see that Jim kind of pulled that out specifically. And of course, the Cunliffe report has talked about asset health. And this is really kind of fundamental. The weather events that we've seen in 2022 and again this year in 2025 have really illustrated that our assets are pretty vulnerable, actually, to the weather that we should now be expecting. And if you look at what's happened in this summer, we've been pretty secure on water supplies because we've invested in those over a number of decades. But leakage levels have dramatically increased this summer in response to record soil moisture deficits. So we need to kind of look at the whole thing. We've got to get that equation right in terms of what we're doing. And just the last thing I'll just say is I'm still, if you come back to the kind of economics of this, it's really interesting. A household in our region will pay around £1.70 per day for, say 400 litres of water, and for that all to be taken away and cleaned back up. This morning I paid £4 something for a coffee in the station. So it's really interesting kind of this point around what are we prepared to pay for.
Thanks, Geoff. And I think this is a good lead then into Martin Andrews, who is the other regulator here in this roundtable this morning. And Martin, you direct Ofwat's major projects team. Can you first explain what are major projects and why do they matter for the water security in this country?
Well, as we all know, the UK is renowned for rain. Unfortunately, it seems to fall in the wrong places. By 2050, 2055, there is expected to be a deficit between supply and demand by 5 billion litres a day across England and Wales. Sorting that out using various methodologies, leakage control, reducing people's consumption, will account for about half of that, maybe 60%, according to DEFRA studies and the NIC. The problem then is, how do you fill the gap? To do that, as has been mentioned, part of the WRMPs, Water Resource Management Plans, back at PR19, identified that there would be a requirement for major infrastructure to be built, new infrastructure, to actually sort out the deficit problem. That infrastructure is going to mean a significant number of new reservoirs, 9 currently, possibly more. Transfer schemes moving water from where it's water rich, which is usually the north, to the southeast, and London is a dry part of the country. And then using new technologies, desalination, water reuse schemes. All of this takes time. Projects have been identified as part of PR24, the Price Review 24, back end of last year. We don't actually determine what those projects are. That was determined through Water Resource Management Plans and through RAPID, which is our partnership with the Environment Agency and the Drinking Water Inspectorate. So between us, we are then required to find how you develop those and deliver those schemes. Now, we're not engineers. Well, there's a few engineers, but I'm not one of them. We're not going to deliver those schemes. The water companies themselves are required to actually develop the schemes, and through major projects, rather than deliver them themselves, they have to be delivered through third parties. There's 2 commercial models that we are using. One is the regulated model. There are no water schemes which have been delivered through that yet, but the Thames Tideway Tunnel, which is under our feet, has been delivered through that and is currently completed and is in commissioning and is operating and cleaning up the River Thames. The other model that we have developed is the direct procurement for customers model. Some people would actually say that's quite common in terms of like PFI, although it is value, is to deliver value for customers. So it is a competitive process. So the water companies themselves will link into that, but they're not delivering it. It's the same with Geoff's reservoir, or 2 reservoirs. They will be delivered by a third party. But Anglian, in this case, will take water from those reservoirs for its own supply purposes. As at PR24, and the numbers have shifted a bit since then, there are 30 projects which have been identified which need to be delivered between now and about 2040. That indicates how long it takes to deliver major infrastructure. And we are talking massive reservoirs and massive pipelines. Shifting water from, as I said, the northeast all the way down into the River Thames area. Not all those projects are going to be delivered at the same time, but the models are continuing to be developed and how to do it. And what major projects within Ofwat does is oversee that process. And ultimately, before it goes out to procurement, we have to approve the model, the draft contracts, and the arrangements which are being put in place. We then, at the end of the process, which could take a number of years, approve the entering into the contracts. Because at that same point in time, we're also giving the water company the authority to collect money from its customers to pay the third parties. So the customers are still paying for it, it's just through a different route. The only project which is currently completed in terms of procurement under DPC is the Haweswater Aqueduct, commonly known as HARP, which was developed by United Utilities over the last 7 years, and it took 3 years to procure it once we've agreed all the terms and conditions, and that reached financial close 2 months ago. So at the moment, we're expecting construction on that to start beginning of next year, but the money's in the bank. I'll leave it at that.
Thank you. And I think, Martin, you mentioned the importance of engineer. I mean, you said you're not an engineer, but you also mentioned the importance of technical specialists, and also Jim in his keynote highlighted the importance of having technical specialists who are needed to design, supervise the construction and the delivery of these large infrastructure projects. So I'm now looking at Tim, and I will ask you on this supply chain that we need to deliver infrastructure. Can you just run us through this supply chain and describe some of the challenges that it faces?
No, thank you. I mean, it's really interesting, isn't it? It's the first time that anyone's mentioned people. This large amount of expenditure to deliver for the UK is hugely dependent upon people and their skills in order to get it right. So, the supply chain, you've asked me to describe it, really it's multi-tiered and multifaceted. We talked about rapid and large-scale water supply projects, but that's one level. The supply chain delivers at multiple levels, down to the replacement of a mechanical seal on a pump that happens day in, day out. And I think people rarely reflect on the fact that the safe sanitation and water supply of the UK is dependent upon thousands and thousands of trained people who operate in potentially unsafe conditions day in, day out. But in terms of water supply, I mean, reflecting on what you're saying about the SRO projects, the strategic resource options. I had the privilege of entertaining a delegation from Taiwan yesterday, and I was talking to them about the large-scale water transfers that we are now looking at across the UK. And I did feel a moment of pride when I'm there, looking at a map, going, actually, we're going to be moving water from the northwest of England, potentially down through the Grand Union Canal. We've got Severn to Thames transfer. We've got potentially a large reservoir in Oxfordshire. We've got 2 large reservoirs in East Anglia, North Links and the Fens. And we haven't constructed a large reservoir in the UK since the mid to late 1980s. The last one that was built was the Kielder Reservoir. And comments were made about it at that time that it was too big. And I'm sure there are people in Northumbrian Water who operate it who will be quite pleased that it's the size it is. So I suppose for me it's a multi-tiered supply chain, which is also operating in a highly competitive environment. If you look at where the UK is, we've got expenditure on nuclear. Sizewell C, Hinkley's nearing the commissioning phase. The Great Grid Upgrade, part of the National Grid Upgrade programme, is at the early stages. And so there's a huge amount of expenditure on UK infrastructure. And this is before the UK government, I suppose, moves to increase levels of expenditure on defence. So even now, probably at the early stages of what is AMP8, I can see a squeeze on the supply chain. So, you're looking at civil engineers, mechanical engineers, electrical designers, programme managers, project managers. And what I'm more seeing is that the skill set of project management and programme management is so transferable between energy, water, telecoms, defence, that at the moment I'm seeing a real squeeze on programme management expertise in particular. But we're having to recruit, to meet that long-term, 10 to 15-year demand. But where the supply chain operates isn't just in design, because often the water company clients are planning, 8 to 10 years in advance. So by the time you get to understand what that plan is delivering, you need to be far more in that far more detailed planning phase. So the supply chain engages in the long-term planning, supporting water companies put their price review documentation together, helping them understand what those options are. And then when it moves into delivery, there's further engagement in terms of optioneering, and then also you're into the on the ground delivery phase with people digging holes, fixing leaks, putting nature-based solutions in, building treatment works, that kind of thing. And again, we haven't built large-scale water treatment assets in the UK really since the mid to late 90s to meet the various drinking water directives. So I can see again, I suppose, a bow wave of expenditure hitting the supply chain over the next 5 to 10 years. I mean, I saw a graduate in our Cardiff office a year or so ago, and I was saying to this lady, I said, look, what an absolute fantastic time for you to join the water sector. You know, you've got 10 years of probably guaranteed career development, a variety of projects to work on. You know, you've really got a springboard. You've got a springboard on your career here to go and work across the supply chain. So I think the supply chain is multi-tiered, and I think we can't forget that it involves people. And some people want to work on projects that will last decades. You know, what I was saying to our Taiwanese delegation yesterday is that some of these water supply projects won't turn to supply till, you know, top end of 2030, 2038, 2040. So some people want to be engaged in projects that will last for half their career. That's what they want, that's what will drive them. And some people want to be engaged in a variety of projects, in a variety of geographies, working on an Anglian water project one day, a Thames water project the next day or week, and potentially working in different sectors. So working in defence in 1 month or working in electricity the next month. So we've got to understand that people enter the engineering and delivery and supply chain sector to support this industry for a variety of their own personal drivers. You know, we don't necessarily, not everyone wants to rotate around the countryside, you know, working in a different city every week. Some people, you know, build homes and families, you know, in certain regions because that's where they want to be, and then they're delivering projects. You know, Thames Tideway took a long time to deliver, but there will be people who have spent the last 10 years on that project and will rightfully sit with pride and go, you know, job well done. I was down at Beckton only yesterday. So it's a complex supply chain. But it's also about having the right knowledge at the right time. You know, I've worked in strategic planning in the water sector for a long time. I was in Yorkshire Water, then Welsh Water before, you know, Stantec, and it's making sure that you draw on that global expertise. We talked about water reuse earlier. Again, there are other areas of the world where water reuse is undertaken, over the Los Angeles Basin, for example, and there's indirect and direct water reuse. So I think trying to pull on international experience is also key. And I think particularly good long-term relationships with supply chain. You know, I work with Yorkshire Water. I've worked with Yorkshire Water over 10, 15 years or so, and it's through those long-term relationships in the supply chain that you understand what trade-offs, I think was mentioned earlier, that the client is willing to look at, and what their long-term goals are compared to others. Whereas if you sit on, say, a panel of 4 or 6 engineering organisations, you don't necessarily know that client as deeply as you'd like to in order to help them make the right decisions. So in order to try and, I suppose, solve the supply chain issue, I look to long-term relationships. Long-term, deep relationships with clients, I think, is critical now more than ever. Because we're looking at, what, a 10-year CSO, 10, 15-year sewer overflow programme. So we're looking at continuity of work. I looked at the graph that was put up earlier around the expenditure of the various AMPs, the infamous Bite in 1995 when Ian Bite decided to cut bills by a certain amount. But if you're working in that supply chain, if you're reaching the end of AMP 7 and the expenditure level drops, there's every risk you might go, well, I'll go and work on Sizewell C, because that work gives that organisation continuity. So we need to look at continuity, and thankfully I think between all of the AMP boundaries that I've seen, God help me, since 1990, we've seen probably the lowest change in AMP 7 to AMP 8, which has given us the ability to make long-term plans, to recruit the graduates and apprentices that the supply chain needs in order to meet that demand signal. Because again, if you're going to meet those 10 to 15-year expenditure plans, you've got to recruit, train, and bring people on, you know, and give them the career that they want. If we're going to look at a spiky expenditure profile where it dips in, you know, 2029, again, all those great people we brought in, we've trained, we've given them the experience of, we've shown them how to operate safely on a wastewater treatment works, for example. We risk them leaving the sector. You know, the government says they're going to put the expenditure up in defence in the long grass post 2030. We risk them leaving the sector and moving to another sector if there is a reduction in that boundary between AMP 8 and AMP 9. So I suppose I look to continuity of planning, long-term relationships with clients, which allows us to build a supply chain that has a really good long-term view of the expenditure profile, but then can make plans in order to look at it, which also allows the client to incentivize the supply chain to perform. Because again, if you're in short-term relationships that aren't built on really, really long-term deep trust, you can't incentivize appropriately. But I think that graph told a picture in terms of recruitment and the ability to retain people within the sector. You know, at the moment, I'd say retention is as key to delivering for my clients as is recruitment.
Thanks, Tim. And I think what you say will be very interesting for a lot of the graduates that are at the conference today. And those of you that are interested in a career in the water sector, you've heard that there are a lot of interesting opportunities to do very meaningful things out there. So it's a great, a really great advert for the sector and the water industry in general. And we've heard from the panel and from Jim's lecture, keynote this morning that there is an issue of understanding systems in terms of change, water quality. Aaron mentioned PFAS, so contaminants of emerging concern. We also heard that there is an issue of understanding human resources, people and their aspiration, and how and when and where they want to contribute to solving water challenges. And we've also heard, I think, Geoff, you mentioned the price of water versus the price of coffee. It reminds me of Adam Smith's The Paradox of Value. Diamonds are useless, but they're very expensive in markets. Water is essential, but no one wants to pay for it. The value of water in exchange is very low. So we still struggle then to understand the economics of water. And this, I think, relates, of course, to economics, but also something deeper around communication. And again, goes back to people, perception, culture, etc. So it's a very, as always with water, is a very kind of you look at the surface, and then there are a lot of interesting, deeper conversations that we need to have, and hopefully we're having such conversation this morning. And so the first part of the panel was a lot about challenges, and we've heard from the US and from the UK, and at the end of the panel, I'll ask the panelists from the UK to mention one thing that they learned about the US and vice versa. But let's now shift gears a little bit to think about opportunities, interesting technologies, governance, financing, and again, opportunities with people so that we can work to address these water challenges. And I'll start with Aaron. I think there was a mention of wastewater reuse. There was a mention from you of PFAS. And in general, I think it'd be great if you could run us through some of the technological opportunities and technological responses that you're exploring at the Central State Water Resources.
Yeah, that's great. So yeah, as I mentioned before, Central States Water Resources, we acquire the assets of extremely old, companies, right? So infrastructure that hasn't been reinvested in a very long time. So one of the things that we try and do most frequently is reuse the assets that are there, right? Rather than do a brand new plant or a brand new process, we try and refurbish and replace what is already existing on site. One of the things that I'm most proud of, and I know my company is most proud of, is we are one of the first people to implement moving bed biofilm reactor technology in smaller systems, right? So in small lagoon type systems. So really what that means is we put a lot of these tiny plastic pellets in a lagoon, and the kind of biofilm, it's a hosting ground for bacteria that exists to clean up that waste, right? So it basically enhances the natural processes that are already happening, and it's much, much cheaper than kind of designing and building a brand new plant, right? And one of the things that was mentioned before is, those people, right? The operators, the people that are actually responsible for running the plants. One of the things that MBBR technology allows is very, very simple maintenance, very simple running of the plant, right? And so as I'm sure it's similar here, in the US we're facing what we're calling the silver tsunami. So a bunch of licensed operators, a bunch of really industry experts are retiring. And the newer folks, newer operators, children, people going through college, they don't really want to run water and sewer facilities, right? And so as we kind of lose all this industry experience and this knowledge, the kind of simplification of processes is becoming more and more important. So really that MBBR technology lets us do a lot of things. It lets us treat to higher standards much cheaper. It allows us to simplify the process for newer operators, and it allows us to use the infrastructure that's already there, which is really, really exciting. On the water side, we use a lot of technology to help us with preventative maintenance. So owning 1,000 plants across an 11-state footprint is very difficult to do from a home office, but we have remote monitoring systems in every single plant that we acquire that tells us a lot of information about that system, regardless of where we are in the country. So what that allows us to do is it allows us to check the pressure. There are chlorine analyzers that allow us to kind of do things remotely. And why that's so important is data, right? So we collect all this data, and we're able to, in a lot of instances, predict where a leak or a main break is going to happen before it occurs, which is really, really important for things like water loss, for things like continued investment. So that remote monitoring technology is really important for us as well. And the last thing I would say is kind of technology from an operational standpoint. So in the United States, we have what we call TMF capabilities, technical, managerial, and financial, that the commission, like the commission that Commissioner Skrmetta is on, kind of judges and evaluates before they allow us to acquire a facility or before they allow us to do a rate increase, right? And I think that kind of making sure that our processes and our procedures and all of that is really up to par and kind of modernized is the last piece that I wanted to talk about. So,
great, thanks, thanks, Aaron, and very interesting innovations that you're working with. And I'll now ask Geoff if any of these sound familiar to you, and what other technologies that you're exploring at Anglian Water to address the challenges that we've been describing.
Yeah, brilliant. I mean, yeah, we've got a number of challenges. I mean, one area I'd like to really pick up on actually is one that Jim raised around water quality, because increasingly we're seeing water quality as a constraint rather than just water quantity, and that's driving us to look at different technologies. And also, as we kind of have exhausted, I mean, these two reservoirs that we're developing, they're going to kind of exhaust the sort of natural, if you like, water that is available within our system. And that's going to force us into, and is forcing us in, to look at other things. So things like reuse of water, and we're currently building a municipal scale reuse plant in Colchester, but also desalination. And the UK's got a little bit of mixed history on desalination, but that's something that we're seriously looking at, both for domestic potable, but also actually for industry to support a lot of the work on decarbonisation. So we're very much looking at that. On the wastewater side again, I was out 10 days ago looking at a brand new algal-based treatment facility to remove phosphorus from wastewater. So we are looking at a variety of different technologies. And I think what we're now doing is having to sort of cast the net wider, I think. So looking at the US, looking at Australia or other countries in terms of kind of what they've experienced on that. Notwithstanding that there are some particular challenges for what we're trying to do in the UK. So not many countries desalinate water that is as cold, for example, as the North Sea. So that's a particular challenge.
And can I follow up, Geoff, in terms of demand management and kind of technologies at that end? What are some of the innovations that you're looking at?
Yeah, so demand management is really, really important. It's actually the thing that's going to make the difference to supply-demand balances over the next 5 to 10 years before new supply solutions come on board. So we're doing a lot of work in that space. I'll just pick out a couple of examples. So leakage management, which I mentioned. And in fact, yesterday I was chairing the National Leakage Conference up in Birmingham. And there's some fantastic kind of innovation coming forward on that. And we're literally kind of throwing the kitchen sink at this issue. So we've got, hydrophones, pressure. We use satellite information now to look at where leaks are in rural networks, as well as looking at sort of new technology on the repair side. And Ofwat's Innovation Fund is really kind of coming into its own in allowing us to kind of explore those concepts. And the other example I'd take is on the customer demand side. So traditionally, we have quite a high level of metering in our region, but they're standard meters that would normally get read once every 6 or 12 months. It's enough to send the customer a bill based on what they've consumed, but it doesn't give them any other insights. We're now moving to smart metering, so we've got around 55–60% of our customers are now on smart meters. So that's recording the data every hour and making that available to customers. And we're going to get to fully smart metered by 2030. And that's proving to be a bit of a game changer for a couple of reasons. One is that it's picking up what we call continuous flows, in other words, leaks in customers' properties. This happened to me. Turned out that I had 2 leaking systems, and they were leaking about 300 to 400 litres a day. And I didn't even realise, right? So, we're picking up some really, really kind of big continuous flows on that side of things. But also it's changing the way that we can start to engage with customers. And here I'm looking at examples from the energy sector. So my energy provider will contact me and tell me that there's free electricity tomorrow because the grid is trying to cope with an excess of wind power. So I can, stick everything on in my house and try to help take that pressure off. We may now be able to start looking at those kind of possibilities with customers. And one of the things that we've been doing over the past couple of years is to have what we call a summer tariff trial. So we've actually increased the price of water for a group of customers in summer, and we're reducing the price of the water in winter. And that is actually also helping to reduce discretionary consumption and helping us to manage peak demand. So there's a lot more you can do when you have that data.
Thanks, Geoff. That's very interesting, and very interesting to hear the story that you were losing 400 liters per day at your home.
Not anymore. All fixed. Yeah.
So I think when we discuss innovation, I think it's great that we started a discussion here on technology, not by mentioning the word AI, which is of course important, but I think in water, innovation is a lot more around infrastructure engineered solutions, things that you need to physically build and test. But I will ask the AI question to Tim. How do you see what kind of technological innovations based on AI do you see in the sector, and do they help to address some of the gaps that we're discussing, including the silver tsunami that Aaron just described?
No, thank you. It's a fascinating question, and we live in a really fast-changing world, don't we? And I suppose we look at AI, and I see almost a polarised view of AI amongst our people and others, is that really early adopters who are just straight out there, how can they do their job better, quicker? And the people who potentially feel threatened by this. And you look at it and go, this is a hugely fascinating paradigm to be in, because almost like you're with the early adopters of coding, you're almost into low code, no code technology now. You ask the AI engine what you want it to do, rather than having to learn Python and code it yourself. But I suppose AI is really, really interesting in an industry that has such long life assets. I bet yesterday you're looking at a tunnel that's got a 100-year asset life. The implied asset life of sewage that we have in the ground, you're getting on for 700 years in some areas if you just look at the renewal rate over the length of sewer that we have in the ground. So I think it's very easy to look at AI as the solution to all the problems, but then we have assets that we're not going to look at for another 400 years. We've got to understand the fact that we are in a very long life asset industry. So I suppose there's maybe 2 or 3 areas where AI is helping at the moment, and we see helping more in the future. Certainly in design, in the signature of the concept design, automating designs and automating design and production of engineering drawings. That kind of stuff is straight out, being able to put the problem into your AI engine and get it to help you design a solution. With that natural word of caution that I found, I'm sure many people in the audience have found, that AI as a tool is not always right. It can easily give you the wrong answer. And interestingly, I've seen some bid requests come out from clients at the moment, and one explicit bid document said you cannot use AI to create the answer. And that's almost like, the genie's out of the bottle anyway. So surely you want your supply chain to use AI in as innovative a way as you possibly can. So parametric design, engineering design, problem solving is where certainly I see that supporting. And in terms of addressing the resource issue, absolutely. I need to recruit another 400 to meet the AMP8 design peak in 2028. I'm not going to recruit 400 people. You can't do it. With a turnover of about 12% per annum. So the best way to address that is to make sure we do work in a clever way by using AI, and in particular the graduate community I've got coming in now are they're on it. They are absolutely fantastic at going. We can do this a different way. So I see a group of the population who almost feel a bit threatened that actually, will I be done out of a job? And my answer to that group I'm seeing and I'm talking to is, hell no. We're just going to help you do your job better, quicker, smarter. So that's, I suppose, one way in which we are using AI already. The second one is in operations. Helping clients. The water sector is a hugely data-rich environment. It's been measured to the nth degree since privatisation in '89. It's a really, really data-rich sector, and it's how do we harness that data and use it in order to operate better, I suppose. But I think we've always got to ask ourselves, why are we asking AI to step in here? What's the problem we're trying to solve with AI, which we can't solve already? So it's very easy to jump to the solution without actually understanding what the problem is you're trying to solve. One example I've looked at is Google Maps for sewers. Other mapping apps are widely available. That tells you when you're at capacity, when you're approaching capacity, or actually if you're coming into a rainfall event, you're running at green, and you know it can take that amount of flow that you require it to. So I think operational activity on a dynamic network is where AI also steps in. And the third area, which I was talking to someone about recently, is about when we build, how do we build AI capability into those new builds. And one of my delivery partners, when I was client side, was talking huge about BIM and all the great stuff that BIM is going to bring. And I'm there going, look, we only touch like 20% of our asset base every 5 years. So you might think you just went and built the Shard and built it with BIM capability, but don't forget that the other assets that I'm not going to touch won't have that. So I think it's how do we build an asset that is not future-proofed isn't the term I want to use, but almost a bit future-ready, that it's ready to accept sensors, that it's a platform as opposed to a delivery vehicle. It's like the military use a warship as a platform. It's not ineffective. It's a weapons platform. I think how do we look at our assets as platforms to deliver service, which we can then build on in the future. And finally, I think that, and this is where it's really fascinating, is drone technology. The growth in drone technology in, I'd say, the last 5 years has been astronomical in terms of asset surveys, 3D mapping. We don't need to send people out to measure assets anymore. We can just use a drone to do a LiDAR map or a point cloud survey. So I think the use of AI to map assets and to understand that the assets that have already been built, what's there, is invaluable. But I think we've got to understand that we still have many bits of equipment that are not tech-enabled. I was working on a supervisory control and data acquisition replacement program, SCADA, many years ago, and my chief exec at the time was horrified that most of the some of the water treatment works were running on Windows XP, and I had to point out that means that there is an air gap, and it is probably more cyber secure than the rest. So the more we use AI and the more we enable our assets, the more we have to make sure that they are secure from a threat perspective. So I think there's a word of caution that we need to make sure we, as well as building in AI capability, we need to build in resilience from a cyber security capacity.
Thanks, Tim. And this point on resilience, of course, engineers think a lot about resilience, but mostly about physical risks, and I think cyber risks are increasingly now important. So we've heard from kind of water operators, technical specialists on some of the technologies and solutions that are emerging, and now we'll turn to the regulators to hear about their perspective, and I'll first ask Martin to also comment a little bit on the point that Tim made around the importance of building very strong relationships across the supply chain to then ensure that, of course, these innovations are kind of deployed at the right moment, at the right time. What is Ofwat's perspective on this, and what are you doing to maintain this continuity of the relationships?
We have recognized that there is a requirement to engage not only with the contracting world, the advisors, but also the financial world, because it all comes together. Because without money, nothing's going to get built. Irrespective of the customers ultimately will be paying, someone has to fund up front. For major projects, and it was mentioned earlier, we really haven't built a reservoir in the last 30 years. You know, the first one, which is being built currently, is Havant Thicket, which is Portsmouth Water's doing. But that's the first one in over 30 years. We've lost the skill set to actually do major infrastructure in the water sector because people moved on to other things. Because there wasn't any major projects being done. The day-to-day stuff, and some of my colleagues will probably shoot me for saying that, which is funded through price reviews, whether it's enhancement or base load, doesn't need to do major infrastructure. Now we're having to build that capability again, both from an Ofwat perspective, because we've gone from 5 people within major projects to 40 in the last 12 months. Each water company that is developing a project, a major infrastructure project like Geoff's reservoirs, need a skill set which wasn't there before. And that skill set is in short supply. So we're seeing the same consultants and contractors on multiple projects. Now, which in some ways is good, because you do get continuity. But does it bring in innovation at the same time? From the finance world, we're actually also seeing an increasing amount of engagement with major projects. Now, we run our own conferences. We do one-to-ones on a regular basis with investors. As part of the HARP procurement, we engaged with all the bidders, and we knew who they were, both from a contractor perspective and from an investor perspective. It's time-consuming, but it has to be done, and we recognise that. Unfortunately, Sir John, in the Cunliffe report, actually did support the major project initiative and said, come back in 5 years to see if it works. I'm not sure what Ofwat will look like in 5 years, but that's a different question. I may have retired by then. But we have to build that engagement with the different people involved in putting these projects together. And we do it on a regular basis. And we participate in events like this, and we run our own events. We have experience also taking information and supporting other countries in their developments. We have a regular meetings with our Brazilian colleagues, Korea, Japan. They've all been through trying to understand how we're doing things from a UK perspective in major projects. But it does show that innovation, though, is not just coming from one place. As Geoff said, there's an innovation fund which Ofwat runs and funds. Actually, today, we've just launched the Innovation Lab, which is actually looking at the demand side, and it's a competitive process. People can bid for money to fund research and technology. So we see there's an importance there in actually developing what the world looks like around us to deliver these projects. But it's a long-term game. You know, as I said, some of these projects will not be delivering in terms of turning the tap on until the 2040s. And quite a few of us will in that silver generation will not be around the time it gets to turn the tap. But we need to educate. So most of the team I've got are under 30. So hopefully they'll be around for a few years as we educate them and they educate other people coming behind them. It's a challenge, though.
Yeah, but
Nice
I mean,
challenge.
we're in the business of education in universities, so we really see the value, of course, of nurturing human capital. I think there will be time for questions. I'll just the questions from the audience, so please prepare your questions. I'll ask one final question to Commissioner Skrmetta to give us kind of a strategic overview of regulating the water sector. What are some emerging trends that you're seeing, and also what are some new uses that you're going to have to regulate in the state of Louisiana?
Sure. Well, you know, it's interesting, and what Tim was talking about the workforce development, supply chain are hypercritical. The other aspect is capital. Our commission we're elected by the public, and we do not have our own funding source to allow for funding of projects. All of the capital that goes into, whether it's water or electrical projects or natural gas projects, all has to come from public sources of capital, private sources of capital. A lot of that is pension fund money. It is decidedly easier to finance gas pipeline and new electricity plants than it is to finance sewage treatment plants because of liability issues associated with that. And so we find that when we're establishing how much we're going to allow for rates of return on the investment, that we have to sometimes allow for higher rates of return on particularly sewage treatment facilities than we do on water facilities. But we understand that the difficulty of providing the capital associated with achieving these products. But because we're dealing with private capital on private projects, that they move a little bit quicker than public projects. And so the actions that are taken, we're not looking at what I would call strategic national projects like they're looking at, but we look at strategic regional or sectional projects that accomplish tasks on a quick basis. So we can have them rebuild water treatment plants in under a year, sometimes under 6 months. Sewage treatment plants take longer to do. In fact, we have some large facilities that are still in sort of trying to develop the mechanization of how to get them built. One of the things that we have been working on, and particularly tying in water resources, Louisiana is now building the largest data center in the world in the northeastern part of Louisiana. It's built by Meta. It is approximately the size of the island of Manhattan. And they, in working out the finance mechanism of this, they have agreed to pay for all of the new generation. But the other issue associated with these data resource facilities is water resources. And, you know, like you said earlier, Louisiana is a water-rich state, but we're looking at the viability of how we're utilizing water resources. We are along our, effectively our eastern border with the state of Mississippi. The Mississippi River, a lot of the facilities are looking at how they can draw water from the Mississippi River for heat exchange, for utilizing that water. Some are drawing groundwater. The Meta Center is buying water from a small town called Delhi in northeastern Louisiana, which has made that city extremely happy that it's now being able to redevelop its water resources and build its water treatment facilities based on that contract that they now have coming in for the next 30 years with the Meta facility. We also are having technical developments of data facilities moving to plant-based oil recirculator cooling devices to offset water cooling facilities. But we're moving into more broad workforce development programs with our universities in Louisiana for several aspects of not just things like nuclear chemical engineering for our new nuclear plants that are being designed, but also how we're going to do for critical planning, critical thought application on project management, how we're going to be working on new development of strategic facilities for manufacturing for developing against supply chain issues. So I think the major thing, though, I think that we probably didn't really super address is accessing capital and understanding, you know, as a regulator, how I have to look at the cost of capital. I have to look at how companies access capital, and I have to look at understanding the value proposition of achieving capital resources to achieve the goal of building out the system that's necessary to provide the value of the consumable utility for the public. And so, you know, we go through a strong analysis. It's not just me or another commissioner. We have analysts that are hired to do this, economists that are hired to do this. And so we go through an extreme audit of the possibles on this, but we try to come to something that is the most reasonable proposition that we can do. Unfortunately, it does drive the cost of the service up, but they also get a system that is now going to be potentially valued to them for the next 20, 30 years, and they're also going to get a water that is going to be water system that's going to be not a ration-based water system, that it's going to provide adequate resources to them, and it's going to be a better quality and better quality of life for them. So I was told when I first became a commissioner some 17 years ago that I had to balance interests between all aspects, and to make sure, in fact, we were looking at Dr. Hill's issue of his triangle of balance, reliability and cost, and the question of impact. And they told me, look, when you are looking at these things, you have to look at, particularly we talk more about electricity in our state than we talk about water resources. But when people go to hit the switch, the power comes on. And when they get their bill at the end of the month, that's the lowest price you can establish the price of electricity for them. But it's the same thing for water. When they go to turn on the tap, the water comes on. When they get their bill at the end of the month, it's the best you can do to establish pricing. The third elements, well, we've got another branch of government to handle that. So, but we try to work and balance those interests.
Thank you. So now I think it's time for a few questions from the audience, and then we'll come back for a 1 minute kind of concluding thoughts from our panelists. Oh, okay. We're having some issues with the mic, so when you answer the questions, please speak up. Sure. Any questions from the audience? I see one here and one there.
Thanks, that's better.
Can you please introduce yourself before asking the question?
Yeah, of course. Can you hear me well?
Yeah.
So, yeah, it works.
I can hear you.
Speak up, yeah.
So I'm a student from the University of Cambridge. Long-term planning. So we've discussed how we need to plan infrastructure on the long term, and with the example of the City of London, so it's around, like it's more than 50 to 100 years of planning. However, we know that there's very fast evolving demand with climatic conditions that are changing like at a very fast rate, socioeconomic factors that are also evolving. So it's more than just looking at 50,000 new people per region, like for example in the east of England. So what are the methods used today to take into account this fast evolving system so that we can plan accordingly on the long term?
Let's take one more question here, and then we'll get back to the.
Yes, thank you very much to the panel. My name's Martin Schuler. I work for Arup. We're a consulting engineering company. I'm the London water leader. So very pleased to be here. Fascinating insights from both the UK and the US. Perhaps just going a little bit deeper and connecting with Dr. Hall's presentation and Eric's last point about those trade-offs. I was just wondering whether the panel might want to reflect on people and communities, because some of these decisions are political in their nature, especially around trade-offs. So I'm just wondering about how do we enhance our community's willingness to pay, but also to value water, both as an engine for growth and for resilience as well. So that longer-term piece about bringing people with us. Are there any differences that we can perceive between the US and the UK, and perhaps some learning that we can share between each other?
Thanks, Martin. So who wants to take the question from Andre on methods for dealing with long-term uncertainty? Geoff, please.
Yeah, thanks. Great question. And we've certainly been looking at this over the past few years, taking a kind of robust, adaptive type approach. So recognizing that we can't possibly predict with any accuracy kind of what the future is going to be like. So we need to develop strategies that can cope with a variety of those. And then put that into an adaptive planning framework with monitoring so that we know when we need to shift. So I think we're doing that quite successfully on the water side now. The wastewater side, the water recycling as we call it, I think there's more to go on that, and it's a different kind of geography. But I think there are kind of routes through the kind of complexity. Thanks.
Thanks. And anyone wants to reflect on the political nature of water and management?
I'll take it. Yeah. You know, surprisingly, nobody likes to pay a higher water bill. The way I work this with companies that come in and seek to get an increase, but they only want an increase because they're doing something, right? And so we'll find that one of the problems we had in the state of Louisiana was we were having our legislature shifted the chlorine content on water treatment through the Department of Health and that deals with drinking water. And in doing so, a lot of the drinking water in some of these smaller was from wells, from artesian wells. And so the chlorine was interacting with the mineral content. So it was changing the color of the water to gray, brown, and so they had to bring in new filters to filter out the... Prior to that, they did not have any color impact with the chlorine, and people didn't have an issue with it. Water's still drinkable, but nobody wants to drink something that's a discolored product. We had to come in and do this. So normally what we'll do is we'll actually have the companies, once we'll go through the process, talk about how much the costs are going to be, look at the cost of capital, look at the actual cost increases. We will require the companies to do a pre-mailing in the bills of the indication of what the potential rate increase will be, to notify the public in advance. We will find that we will always have a small percentage of the customers will raise questions, and they will contact the commission directly, and they will talk to our staff. We have a small staff in our regions that will talk to us about these issues, and we will explain the issues. Usually that will not solve the immediacy for everybody. We will then have a community meeting. That will not solve the problem for everybody. There will always be someone who is unhappy. But at the same point, you can't make a political decision based on a few people when you're having to make a decision on the body of people who are going to benefit from the action. So, you know, the tallest tree catches the wind. So if you're going to be in this and you're going to be in a position to make decisions as a regulator, you have to make decisions. And so if we want to make sure that the quality of drinking water is something that people can ingest and be happy with, and it's going to cost money to do it, you just make sure that the money is the cheapest that they can achieve, the proper manufacturing processes and the implementation of the services there, and you have to do it and you have to make the decision. So we do so, and that's sort of the process that we go through.
I'll add one thing very briefly. As a utility company who kind of comes in and raises rates, sometimes pretty high, one of the things that we try and really make clear is that the price of water is not going down, right? It's only going to go up from here. And really it's about ensuring that customers and the ratepayers, the people who are actually consuming your product, are aware of the value, right? So education is huge there. So for our communities, we do a couple things. Anytime we come into a new community and start, providing service and reinvesting in their system, we give them what we call a state of the facility letter, which basically just kind of details their water or sewer system and all the problems that we've seen with it, right? All the issues that have stemmed from a lack of investment. What I've noticed, and I'm relatively new to the industry, I've been in the industry about 5 years, Before I got in, if my toilet flushed, I didn't really care, right? And I think that's what a lot of our customers see. If they can flush their toilet and it leaves their house, they don't really think about what's happening on the back end of that. So really just trying to educate those people as to the value, you know, ensuring that they understand that if we didn't treat it on the back end, the waterways, the environment would be negatively impacted. And I think just kind of raising that level of awareness has been really, really impactful in the communities we serve.
Thanks. Let's take 2 more questions, and then we'll have a final remark from the panel. 1 question here.
Hi, I'm James. I'm focused on recruiting into the water sector. Quite a few of you mentioned, Aaron, I think you mentioned the silver tsunami, the retiring workforce. So I'm quite interested in what you guys think we can do, what companies and utilities can do to attract more young talent, how we can beat out other sectors in attracting more talent, and also retaining as well, because obviously it's more expensive to just recruit.
Who wants to take this question? And then we'll have a final question up there, I think. Yeah. Geoff, and then Tim.
Yeah, I mean, recruitment's really interesting. I mean, Tim's mentioned the kind of numbers that we're talking about. I mean, we came into this 5-year period with about 80% of the work basket recruited through alliances. We've had long-term partnerships with companies, and we think that's quite successful. We've also had a lot of interest in working on our major infrastructure projects, so people are quite excited by this. And that is both sort of younger people coming out of university, but actually also people probably more my age who want to do kind of one big final project before they retire. I probably worry a little bit more about the attractiveness. So, if, my son's at university at the moment, so what does he think of the water industry? I think he wants to go into Formula One rather than into the water industry. So yeah, how do we make it more attractive? But I think there's a huge amount of kind of possibility, and I think we've got a role working with universities to kind of open people's eyes to that.
Yeah. You want to comment? Yeah.
I suppose it's a really kind of big conundrum, isn't it? It's how do you attract people into a sector which gets an awful lot of bad press as well. I think it's understanding what the offer is in particular. Longevity. We have long life assets. We have long life projects. People can start with a project and keep going. And I think what's different to some sectors is also the environmental value that people add. If you look at the good that's done by the sector to the wider environment, people can really make a difference. I've been involved in environmental investment around the UK for nearly all of my career. So it's amazing to see the projects that you get engaged in. But to address the silver retiree, the silver tidal wave problem, I think the sector also offers more flexible employment models than others. In terms of flexible working hours. Flexible locations, and the ability to work differently. The COVID pandemic opened our eyes to different ways of flexible working. But having gone from an organisation that you have to work 5 days a week or you're not going to be working, to actually we'll find a working model that matches your lifestyle at that particular moment in your life is very, very different. And so what the sector needs to broadcast, I think, a bit more to the recruiting community is the fact that actually it's not necessarily going to be a 5-day-a-week employment model. It's an employment model that you can flex depending on what your own personal needs are, which I think is often undersold. And I think we need to sell the benefits of the employment model a lot more because it's a 24/7 business. But that has benefits as well as the downside.
Yeah. I would add one other thing, that the UK's silver tsunami is more accelerated than the United States, because the average age of the UK citizen is about 42, I believe, and the average age of the United States citizen is about 35. And so they're going to age out quicker here. And so the opportunities are going to be greater for young employees to excel into the industry. And so also I would add that between the advent of the new nuclear systems, the advent of new water systems, the advent of new whole utility systems, these are career opportunities that you will start and you will finish and through full retirement in this type of industry. So you're not going to be wondering, oh, this project's over. The answer is there's going to be the next project, or this project is going to grow to the next project. So it's going to be a life opportunity.
I think, yeah, and one thing I'll add is, of course, working in water is also working on climate adaptation. So I think for Gen Z interested in acting on climate change, of course, a career in water is a great choice. Let's have one final question from up there. Thanks.
Thank you. Rich Simons of Aquasense Technologies. We manufacture disinfection hardware. Given the need for the innovative projects set out through 2040 to meet the urgent demand of water production, and the actions of the Innovation Lab to try and bring new technologies forward, particularly thinking about hardware rather than AI solutions, do you think enough is being done to join the gaps between the enhancement at the early stage of new water treatment technologies all the way through to regulatory acceptance, and especially given the longer lead time of these major projects, 8 to 10 years, decisions being made very early on what that site will look like? Is enough being done to bring the new technology forward so that the point of commissioning is using the latest available technology to the best of its extent?
The commissioner says no, not fast enough.
Martin,
I was about to say, from an Ofwat perspective, we're quite comfortable with new technology, but we don't get to choose. That goes with the quality regulators, either the EA or the DWI. Now, we know they are under-resourced, and they have issues that they need to resolve in terms of approving things, DWI especially. The new arrangement, and I have no idea what it's going to look like because I have not seen the white paper yet, may actually try and resolve that. Now, we're trying to push things forward as fast as possible. There is an impetus coming from government to deliver these major projects faster and cheaper, of course, but faster than is originally planned. And to do that, we're going to have to pick all the pieces of the jigsaw puzzle up and work out how it works. That includes technology. But things like technology also has an impact on customers. You know, we're talking about using reuse schemes from sewage treatment works. Just the thought of that has a reaction from customers. So again, you need to convince customers that they're not going to be killed by just turning the tap on. So, but there's a lot of things like that which need to be delivered, and technology will help that.
Thank you. Let us conclude with just 1 minute takeaway from each of the panelists. It can be on what you learned from the other side of the Atlantic or anything else you want to highlight. Let's start from Tim.
Yeah, I suppose, having worked with my colleagues in the US, I'm always really amazed at how many water undertakers there are across the US. You know, you talked about how many there were in the state of Louisiana, and you know, managing to work with and regulate many thousands of water undertakers is always, to me, absolutely mind-boggling. So every time I look at that and go, that's just a completely different scale. So I just take that on board every time.
Yeah, for me, I've always been fascinated. I've been working in and out of the UK since 1986, and I've always been fascinated by the magnitude of early engineering of systems in the United Kingdom and how long they've lasted. And I think we've lost a little sight of the potential of continuing long-range infrastructure development, how we should be looking at 100-year cycles, not 30-year cycles, and I think particularly in this industry. So I've always been super impressed and continue to be by the UK's engineering systems.
Yeah, I think for me, just the stark difference in the number of kind of major projects, I think kind of stood out to me. So, you know, I heard, 10 to 40 major projects. I think, you know, in the 6 years that I've been with Central States, right around 6, we've brought about 250 plus systems from non-compliance to compliance through major engineering projects, right? So just the kind of difference in scale of, you know, not just the number of systems, but the number of projects, the number of major kind of engineering expansions really stood out to me today.
The one interesting one to me was the commissioner's comment about Meta's data center, because that is an issue we're facing here. You know, where do you put data centers? Because they need electricity, but they also need water, unless you can find an alternative. Why should they all be located in the southeast of the UK when all the water is in the north? And unfortunately, I think electricity does go down wires at the speed of light. So why not do it there? So I need to look at that Meta one.
Come visit. You're invited.
Thank you.
Geoff, yeah.
Yeah, I'm speaking at a conference here in London next week, and next Monday actually, on data centers and water. So it'll be it's a hot topic. Yeah, a couple of takeaways from me. I mean, one, you know, there's been a huge amount of noise in the UK, you know, around the kind of commission and everything that's kind of gone on before. Actually, you know, sitting back, listening to experiences and listening to Jim's comments around, you know, the state of the world, actually, you know, we've done an awful lot of navel gazing, you know, and actually our problems are not maybe quite as significant as we think they are. The fact of the matter is you can still turn the tap on anywhere in England and have, you know, really clean drinking water. So we mustn't lose sight of that, I think. The second thing, reflecting kind of on the US examples, I think it's, and more broadly, it's sort of, you know, we've got to get quicker at getting things done. And I don't just mean building stuff, I mean the regulation of stuff as well. And if you look at what's happening in California, the way that, you know, and California, by the way, has got some of the highest environmental standards in the world, but they've managed to get, you know, groundwater reuse sorted out. I think that we've got to move quicker, and so that's one of the things that I'm going to take away. Thanks.
Great. Thanks. And we got an invite to visit the state of Louisiana, so that's a great achievement for the panel. Thanks to our panelists. Thank you. And we'll now move to the next segment of the conference. Thank you.